Cool. Hello, everyone. I'm Connell Watkins. I am the Principal Platform Engineer at Oakbrook Finance. A few of us here, we are sponsors. At Oakbrook, we've been on a bit of a journey over the last couple of years, building a whole new platform in, well, DDD and CQRS and onion architecture. So I'm going to take you through sort of the things I've learned and hopefully teach a thing or two. So just pre-warning, there are going to be lots and lots of arrows in this talk. It's diagrams and boxes, and it's also going to be, well, the arrows mean dependency. I'm not using UML or any notation really, that's just this knows of that, because we like to personify things. We like to say, this doesn't know that that's allowed to happen. And contract knowledge, the public contract I mean, not the internals. And there's going to be a lot of fancy animations like that. If you saw Matt's talk earlier and you like them, you're going to love this. I do apologise if you don't like them. I've got a lot to get through, so questions at the end, that's okay. If time allows, I'll maybe stop between these sections. So we're going to do 20 minutes of boxes and arrows, and then the animations will die down a little bit. I'm going to start building up the onion architecture from the middle. So I'm going to do the domain layer in DDD, and then I'm going to do the layer around the outside of that, which is the application layer in CQRS, and then about 10 minutes at the end of infrastructure. Very rough, that is. So I'd like to make a big statement at the start and say, software is about drawing boxes. Not to diminish anybody who's been doing this for 10, 15 years, but software is about drawing boxes is the first statement I'd like to make, because we don't just write everything in the main function, we like to draw boundaries around things, and we like to simplify the problems so they have fewer things to worry about. So here I've got 4 boxes here, I've got some methods, I'll draw some boxes around those and I'll call them a class. And then maybe I'll say one of those classes, or maybe I'll say one of those methods is private within the class, because we think these methods are related. So I'm going to draw a box around that as well. I'm going to call that a class library. And then I'm going to draw another one of those over here, and this is the same thing, it's another library, but this one's got some meaning to it. This one's an API. And the class in there we call a controller, and the methods in there we call actions, some of them, anyway. So, oh yeah, and then we'll draw even more boxes. We'll draw boxes around that, and we call them a solution, or service, or a component. So it's all drawing boxes. Hopefully I've convinced you it's all about drawing boxes, and there's the animation, boxes and arrows. Software is all about drawing boxes and arrows, because once we finish dividing everything up, we stitch it all back together again with some arrows. We say, the API layer knows of this library. This is dependency, remember I was saying. This class might know of this class. And then, can we do that? Nope, can't do that, because that would create a circular reference. So we have a direction of dependency. We say it can only go one way. This can know of that, but that can't. You can technically do the same thing with your classes, but your code quality tools will probably say that, yeah, highly coupled things together, and it's not very cohesive. You can do the same with the big grey box on the outside, if you like. Know each other's URLs, but again, why would you want to do that? So hopefully I've convinced you that software is just about boxes and arrows now. How many people recognize these boxes and arrows? We've all worked in N-tier applications, surely. So in a traditional N-tier application, we've got the 3 layers, presentation, business logic, and data access. So again, I mean dependency. The presentation layer knows of the business logic layer. The business logic layer doesn't know that it's part of an API. Data access puts things in a database, but it doesn't know what the logic is above it. And then I want to introduce this second arrow. Now this arrow, why has he done that? He's just going to put another arrow pointing the exact same way. So this arrow is the flow of control. Now this is subtly different. So whilst dependency is I know of this thing, control is I tell this thing what to do. The business logic layer tells the data access to go and put something into a database. So it's making the call. If I put a breakpoint in my repository and I looked at the call stack, I would see that it's being called by the business logic layer, which is being called by the presentation layer. So it's about calling, it's about driving, it's about telling it what to do. So that's the second arrow. Now, take a look at the black arrow between the service and repository. You ready for these animations? Whoa! Let's go the wrong way, look. There you go. Did you see that? Not the new arrow that's just appeared on the screen. The arrow that the new arrow is pointing at is now facing a different direction. Let's zoom in. Like that. Dependency inversion. We've now got the flow of control is still going the same way as it was before. My service is still, or my business logic is still calling in to my data access, but the data access knows of, it understands what the business logic layer is. So before we go into why you would want to do this, I'm just going to explain how. We add an interface. This will be your iRepository. So you've got a repository implementation, an iRepository over here, and a service that's using the repository there. So these are not UML arrows, like I said. These black arrows here just mean know of. Like one would be in UML the implementation, one would be this just uses that. But you're probably used to seeing it over there, right? In your data access layer, where you've got your iRepository and your repository implementation sitting in the same project. But all I've done is move it back. All I've done is move one code file. I just went to drink my microphone then. All I've done is move one code file, and I've changed the direction of the dependency between the boxes on the outside, the blue boxes, the projects. So just if you didn't get that, I've got one more way of explaining that with some code. I'm glad these screens are massive. I was worried if we were not going to be able to read that. So I've got a talk service. It's a talk about a talk. It's a talk. And then you've got that uses the repository, and then I've got my entity framework repository implementation here. And all I've done, if you check the top bit, is draw the boxes in a different place. I've not actually changed anything in the code. I've just drawn different boxes, and now I've changed the direction of dependency. So that's dependency inversion. So this is called ports and adapters. The interface is a port, or actually it's the interface and the model that's used in the interface is the port, and the data access layer is adapting that port. It's implementing that interface. You can think of the port as kind of like the business logic saying, I know how to use this repository. I don't know how to implement this repository, but it's public, and it says, anybody that knows how to implement my port, please do so. Please adapt my port. And then the data access layer does that by using the adapter pattern. It's an adapter. So you might have your iRepository, and then this repository wraps up another repository. It implements one interface and encapsulates another. It's the adapter pattern, the gang of four. So interesting to note here is the business logic has no transitive dependencies. There's no black line going this way. So the business logic doesn't even know that Entity Framework or MongoDB we use at Oakbrook doesn't even know that these technologies exist. You couldn't even accidentally use your stuff from your Entity Framework libraries, like your attributes. Like if you wanted to say that this object has a primary key that's this property, you can't. You can't even accidentally do it. Entity Framework gets around that by providing a fluent interface, which allows you to, in your DB context, in your data access layer, you can point at the port and say, this is the primary key from the outside. So it supports ports and adapters, or that dependency inversion. And then this is the other side. So the other side, note that now my controller is still pointing at the business logic. So that's still going the same way. But if you look all the way over there, my controller is pointing that way at MVC. My controller knows of ASP.NET MVC. It understands what MVC is, because I have to implement it. I have to inherit that, or derive from that base class. I need to use the HTTP GET attributes. But the flow of control is still going the other way. It's still going this way. My controller, or ASP.NET MVC, sorry, calls my controller. If I put a breakpoint in my controller and I looked up the call stack, it's calling me. If I put a breakpoint over here, the call is all going that way. But I've inverted it. So yeah, frameworks do this all the time. The frameworks are obviously inverting the flow of control all the time. It's a very common thing. And that's basically the controller is another adapter. Now look at the one in the middle, the business logic layer. It doesn't depend on anything. It's perfectly pure in the middle. It has no external frameworks, has no extra dependencies, it doesn't depend on any projects at all. It's very pure. So it's very easy to test, because we don't have to write any tests that call into a database or make an API call. It's just C# or Java or whatever your weapon of choice is. And that is shapes and boxes and arrows. And I'm way ahead of schedule, so I'm talking too fast. So hopefully I've convinced you that software is all about shapes and boxes and arrows, and that is ports and adapters. This is one I've liberated from the internet. So I didn't draw this diagram, and this is the ports and adapters architecture diagram. Big problem with this is not enough arrows. So all of the dependencies go inwards. The API, like I said, knows of my business logic. The database knows of my business logic. They've actually got some other examples here as well. They've got a console application that calls in, and you've got a message queue at the back end there as well. Maybe HTTP, you've got external API calls happening at the back end as well. The flow of control goes that way. So this is, you note this diagram is split into primary/driving adapters and secondary/driven adapters. They're just two, they're interchangeable terms. I prefer driving because my API is the flow of control. It drives the business logic. It tells the business logic what to do. And then on the other side, the driven adapters, the database is being told what to do by the application. Even though it depends on the application, it is being told what to do, so it is driven. The business logic drives these adapters on the right-hand side here, and the flow of control goes this way. And that's ports and adapters. That's the ports and adapters architecture. Everything, dependencies go inwards, flow of control goes from left to right. That is, or I think was originally called Hexagonal Architecture. I'm going to swap hands now, that one's getting tired. Hexagonal Architecture was the original name, and I think somebody said we should call this ports and adapters instead. Probably because there's no reason this should be a hexagon. As far as I'm aware, it's nothing to do with the number 6. There are 6 things on here, but your web services probably don't have a console interface as well. You might not be using a message queue. So there's 6 on here, but you can have as many adapters as you want on either side. It's a hexagon because we like shapes. I'll swap back now, it feels uncomfortable. We like shapes, we like these visual cues. We like to think about problems like in shapes. We like to visualize them. We don't like thinking about all this code put together, so we put shapes to it. So this one's a hexagon. It doesn't mean anything, it's not about 6. So on shapes, here is our n-tier or layered architecture. Again, visual. We've got these layers like that. It kind of looks like a cake. I'm not doing a cakes have layers joke in an onion architecture presentation. No, not gonna bite. I made one. Olympic rings architecture. I thought I was being really, really clever here. So a couple of years ago, I came up with Olympic rings architecture. It's got 5 projects. Dependencies look like this. So you could say direction of dependency goes downwards, and the flow of control goes from left to right. 5 projects. All I've actually done here is if you say those are the same project and they're the same project, that's an n-tier architecture. Or if you said those are the same project, that's ports and adapters. So I thought it was being really clever. This one's a cone. Or any geometry nerds? No? I won't give you its real name. The cone is just a slice of this circle. Clean architecture. What's wrong with this diagram? Not enough arrows. The cone had arrows on it, didn't it? So the clean architecture, dependencies go inwards, like your ports and adapters. Dependencies go inwards. And then we finally get to onion architecture, which is what I'm going to talk about. So, clean architecture, onion architecture. Very much the same idea. Dependencies go inwards. In fact, I think clean architecture is like an abstraction or a spec, and onion architecture is an implementation. Not that it matters. We've got these visual cues. It's an onion. You like to think about this as a circle that you can peel away these layers. I can peel away my presentation layer, and underneath it, there's this application layer that you can see. And you can peel that away, and there's a domain layer underneath that. So we've got these visual things, these prompts that help us. But it doesn't matter. It doesn't have to be an onion. It's not about onions. And to prove that point, I invented castle architecture. This is exactly the same thing. It's exactly the same dependencies, exactly the same architecture. The code is completely the same, except I've drawn the diagram like a castle. I really tried to animate this one. I really did. Imagine all that coming out and landing in a castle shape, but no, my keynote skills are not that good. So am I just saying in all of this that onion architecture is just the hexagonal architecture, the ports and adapters, with a domain in the middle? Yes. Yes, that's exactly what I'm saying. We split our business logic into domain logic and application logic, but everything on the outside is just the hexagonal architecture, except it's not a hexagon. It's a circle, and we call it an onion, because it's got layers. So we split the logic up. And now, what was that? Oh yeah, I'm finished on boxes now. So that's all the fancy animations done. What time are we on? Okay, I'm going to go into build this now. I'm going to build from bottom to the top. I'm going to start at the domain layer, and you can imagine me sort of doing these building blocks, and I'm going to build outwards and build up a sample onion architecture. Does anybody have any questions on shapes and boxes, by the way, before I move on to domain? I'm a bit ahead of time.
What's your favourite shape?
Oh, well, hexagon? Onion, is that shape? No. No? Cool. All right, let's have a look at the domain layer then. So, this is a very, very boring diagram. Call it the flag of Japan architecture, if you like. There's no dependencies, no arrows. It's like our business logic imports and adapters. Very pure, it's in the middle, very testable, very easy to write unit tests around this. There's nothing going on, it's very simple. And now we're going to have a look at what it's all about boxes. We're going to have a look at what's inside this circle. And we're going to use domain-driven design. See that animation as well. So, what is in domain-driven design? The building blocks of domain-driven design then, we're going to find in our domain layer. We're going to find aggregate roots, and we're going to find entities, you might have heard of them, domain events, there's some of them in there. Oh, and there's value objects. Oh, but stop! Just making sure you're all still awake. Not bored you with shapes. So, this is the biggest mistake everybody makes. I've made it. I don't think I've seen anybody not make it. Domain-driven design is not about aggregates and domain objects and value objects and all that stuff. It's a business first. It's domain first. It's in the name. It's designing your software driven by the domain. So it centers around this domain model. It actually says the structure and language of the code should match the business domain. That's what domain-driven design is about. So it's not about all this technical jargon. It's actually about, ironically, not using technical jargon. So we don't use HTTP client or whatever provider, all of these nice technical words. We try and talk in the same language as the domain experts. It's about a collaboration between us, the technical experts, and the domain experts. They will be people that work for your company that aren't technical. So at Oakbrook, for example, we worked on a payments domain. We had the finance team. They're experts in payments. So they are domain experts in that example. And we worked together to develop a ubiquitous language. Ubiquitous language is what we all agree we're going to use to talk to each other. So this is the stuff that you're going to put in your requirements. This is the stuff that you're going to use in your meetings. This is the stuff that you're going to write on the board and use in your stand-ups in the morning. It's the stuff that the same language everybody's going to talk to each other in, and we all agree that we all know what these terms mean. Build yourself a glossary of these terms. Define them. I went to a Scott Voloshin talk at NDC in the before times, and he had this example in F# where he said he was doing DDD and he's got this F# code, this domain code, and he showed it to the non-technical domain expert, and the domain expert says, yes, that's how I understand the domain. That's how I understand it. Where's the code? And there you go. That's the dream. That's what we want to strive for. I know in C# we've got to use keywords like public and class and static, but if you strive for, having code that your domain experts can read, then they can do our PRs. So there's a whole culture around domain-driven design. It's not a technical thing. It's a whole. Everybody needs buy into it. And I was going to then refer you to Lucy's talk, who would have been talking about the culture of domain-driven design after this slot. Unfortunately, Lucy can't make it, so I can't. So I get to talk to you about domain events. You know when I said the first mistake everybody makes is doing the technical bits first? Well, I'm going to do that. I'm going to talk to you about all the technical bits. So domain events. Something has happened. Some state has changed in our domain. Now, these are written in the ubiquitous language. I'm going to stand over here. I've given this side enough love. These are written in our ubiquitous language. So something happened. So let's get some examples. We've got account registered event, payment made event, talk started event. These are domain event examples. They're using our ubiquitous language. I've forgotten what I was going to say next. Oh yeah, there is a bit of culture in this actually. I will go on about this. To come up with these, there's a process called event storming, where you can sit and talk to your domain experts and just get them to tell you a story. Just get them to say what happens in their domain. Because when they're describing their domain, they're going to say things like, oh yeah, somebody makes a payment. They don't create a payment, they don't add a payment or anything like that. They say they make a payment or they take a payment. So you use this language in your domain events. Oh, one thing to note here is I'm using init-only properties, the C#9 feature, because domain events are immutable. Once I've created these, I cannot go and change them. They are immutable objects that cannot change once they've been initialized. For example, the talk started event there, I can't go back in time and change the speaker, as much as you all might like now. You can't go back and change who started the talk. The speaker object itself also would need to be immutable. And note that these are written in past tense. They've already happened. It's not this talk starting. Move on for them. So I'm going to try another diagram. This is going to be a sequence-ish diagram. So the big red circle, remember the flag of Japan, is the domain. That's the domain layer. And then from outside the domain, somebody says, do the thing. Tells the domain. So it sends a command in, and it knows of what the thing is. So the thing outside the domain references the domain. It understands what the domain is, and it sends a command that says, go and do the thing. So the domain goes off and does the thing. And then it says, something has happened. The domain event, something has happened. And it publishes that event. That goes out. It doesn't know who's listening. Doesn't know who's listening to the domain event, because the listeners, or the subscribers, before the domain event happens, they come along and say, I want to know when something happens. Tell me when something happens. So they understand what a domain event is, but see where I'm going with this? The arrows. The flow of control is going out of the domain, but the dependency goes into the domain. So domain events, like ports and adapters, are just another way of inverting the control. Oh, I accidentally clicked. Entities and value objects are two other forms of objects you're going to find in the domain layer. These are very distinct. Entities have reference equality, value objects have value equality. And by that I mean, if you have two entities that have exactly the same properties in every way, and you compare them, they're still not equal, they're still different objects. Whereas a value object, if they had the same properties in every way, and you compare them, such as an address, you've got the same street, same city, same postcode, and you go, are they the same address? Yes, they are the same address. So they're a value object, they equate by value. Entities are mutable, value objects are immutable. Like the domain events, you can't change a value object, it is what it is. But an entity, you can go and change. You can change its properties and it can change over time. So a value object has no lifespan, it just is what it is, whereas an entity has a history. And it is that history that is the domain events. When things happen, an entity changes, that's a domain event. Aggregates. Now this is an aggregate. I'm really, really unknowledgeable about cars, by the way. So this is an engine. It's another box. You've got a door. These will be entities, because I'm bad at cars, but there's a thing called a V8. You can have two V8 engines that are the same in every way, but they're not the same actual engine. You can put them side by side, and well, they're not the same type of engine. So these are value objects. Same with a door. You can have those fancy doors that like open sideways. They might be the same type of door, but they're not the actual same door. Same with the lights. You can have those horrible yellow ones. Wheels, mirrors. But the color is a value object. Or maybe in this domain it's a value object. Because if you had two red cars, let's stick with red, we're in the domain layer. If you had two red cars, and then you took their color property and you compared them, and you said, is this the same color? Or are these the same color? Yes, these are the same color. They're both red, so they equate by value. So they're value objects. And we draw another box. We draw a box around all this and we call it an aggregate. The car is also an entity. So if you were thinking like your SQL tables, you've probably got 7 tables here, and the car would be an entity just like the others. But the car is the aggregate root. It is the way in. So the aggregate provides a consistency boundary. So the aggregate is where you can put your domain rules. You can say a car must have 4 wheels, or maybe 3, but not 2, that's a bike. You can put other domain rules in there, which I'm not going to go into. So the aggregate root is like the way into the aggregate. It's the only way into the aggregate. So if I was outside of this box and I wanted to make a change to the wheels, I wanted to slash the tyres of the wheels maybe, I can't just say slash tyres from wheel 1, 2, 3. I have to know the car ID to know the wheels to go in. Maybe a more appropriate example would have been like, driving a car. That's a bit more appropriate, isn't it? Driving a car, you don't drive each wheel individually, you drive the whole car itself. So that's an aggregate. And here's some code. This is how you might choose to implement an aggregate. There's no real rules. This isn't even exactly how we've done it at Oakbrook either. I've said a car is an entity, and it's also my aggregate root. And then I've got some properties here. I've omitted the constructor and some other properties. And then I've got this method, paint body. I'm using the ubiquitous language. So it's not set color or any set body color. It's paint the body. And then I've got some domain rules. If the color is yellow, we don't like yellow cars. If there are any lights, nope, you can't paint the body because there are already lights installed and you're going to paint your lights. Then I do actually set in the color. And then I add the domain event. So I add a body painted event, and I initialize some properties there. Note that I'm adding it to a collection here. I've got like a domain events collection. I'm not actually publishing it at this point in time, which I will get to later. So that's an aggregate. And then you've got data abstractions. And these are abstractions. So this isn't my database. Remember, ports and adapters, these are like your ports, saying, if anybody knows how to do repositories, please implement them. And my repository is just like a bucket where I can put aggregates. And it is aggregates that I put in the repository, not entities. So I can't go and put wheels. I don't have a wheel repository. I can have a car repository where I put the whole lot. I found this easier to grasp after working with a document database. So working with MongoDB, I just put the whole car in with an array with the wheels. It made a lot of sense to me when we say these can only be aggregates. Maybe the concepts there combine. So that's the repository. You add things to it, you get things back out. The unit of work is an abstraction for a database transaction. So I can make as many changes I like to my repository. I can add 7 different things. But they don't actually happen until I commit that work, until I say all of this work that I've done, that's a unit, and I'm doing it at once. I either do it or I don't. And then your data abstractions. Now, I'm still talking about the domain layer. Now, this is a mistake we made at Oakbrook as well. It's really easy to consider these outside of the domain. It's really easy to consider these technical things. So we put them in the application layer at first. I like to sort of think about it like this. It's kind of in a really thin repository layer just outside the domain, and dependencies go inwards. So the repositories, they know of my aggregates, but my aggregates aren't going to be committing units of work, or they don't know of my repositories. So it's like a thin layer just on the outside. And that is the domain layer. So I'm now going to talk about any questions on DDD, domains, or anything like that, before I move on to what's outside of that? None. Silence. I'm either doing really good or really bad. Outside of the domain layer, then, we have an application layer. And in onion architecture, dependencies go inwards. So we've implemented this as just a domain layer, so it's the application project references the domain, but you can kind of see it's like going all the way through. And how are we going to do it? CQRS. These are going to be the boxes inside our application layer. So what's in the application layer then for CQRS? Commands and queries. And that's it. Again, it's kind of in the name. Command query responsibility segregation. We are segregating the responsibilities of our commands and our queries. Before I do CQRS, CQS came first. Basically says a method or a function can either read or write, but not both. Definitely not both. And that's it. If you're writing, if you're making changes, you're having side effects for the thing you're calling, return void, or maybe a task if you're doing it asynchronously. And if you're reading something, don't make any changes. No side effects if you're returning data. So you can read as many times as you like, and you know you're not changing the system. So that's CQS. And CQRS, add in the responsibility segregation, takes that a step further and says rather than just functions or methods, entire subsystems. We're going to separate entire subsystems for reading and for writing. Half of our application layer is concerned with the commands, the writing, and half is concerned with reads, the queries. The key point here is it's not CRUD. You're not putting in the same object. I think I have to drop my clicker for this. So we made this mistake at Oak Brook. I think we might still do. Because we're designing REST APIs. We're putting REST APIs in our UI layer. And I think when you think about a REST API, and you think about that state, you think put, my HTTP verb put. I've got an object of this shape, and I go put that at that location, and then I kind of expect, when I'm transferring that state, to be able to go and get that same object back in the same shape when I do the read later. That's like thinking like a REST API, I think. And that is not CQRS. That is, in fact, the opposite of CQRS. In fact, CQRS says one thing, and it's don't do that. So I think REST APIs make that quite difficult to think about if we're designing REST APIs around CQRS. Instead, think task-based. When you're doing your command side, think, what is it I'm actually trying to do? Stop thinking about an object that you're putting somewhere, or you're changing. Think about the task that's at hand. And when you're doing your read side, think about what it is you want to read. Think about your view model. Think about what it is you're trying to get. What data am I interested in here? And that's CQRS. It's split those subsystems into two. And I'm going to do another weirdish sequence diagram, this time with a big blue circle. Remember, that's the application layer. The big blue circle is the application layer. And then from outside, we say verb something. They're all verbs. So like make a payment, start the talk. So we verb something. And then inside the command, we've got a handler. We've got a bit of code. This gets quite messy, and I do apologize in advance. We've got a handler, which is actually in the blue, well, lives in the blue circle. And the handler says, go and load me the aggregate. It goes repository.get. So it's talking to that pinkish layer, that repository layer. It says, go and get me the aggregate from the repository. And then I'm going to go and do a thing. I'm going to mutate that aggregate. I'm going to call, maybe paint the body, if it was the car. And then I'm going to commit my unit of work. I'm going to say I'm done making changes now. You can save that transaction. Well, that is my work. Commit. And then I return fulfillment. And that's it. That's the command handler. Now I'm returning fulfillment there, remember. Commands don't return anything. Commands don't return, certainly not any business data. Note my return type there. I'm returning a task. I could also throw an exception, though. So you can return errors from a command. Or at least we have decided. You could actually return, say you've got a command result object that's got information about the command execution. So you can return the fact that the error is there, you can return an error message. I've sort of toyed with the idea, maybe you can return like the number of rows that were affected. I don't know, kind of like a non-query in SQL. Don't know that one. So you can return fulfillment or error. There is another school of thought. If you've got like a command bus, if you're using RabbitMQ, and you're doing everything asynchronously, putting your command on the queue, you haven't actually committed the unit of work. Or you haven't actually done the thing. It hasn't been handled. So instead, you return acceptance, you return or acknowledgement, and you say, I will get around to that. It's like an asynchronous 202 if you talk in HTTP status codes. So the key point is you don't return read models. You don't return anything from the query side. These are entirely separate subsystems. OK, so I can do several changes within a command handler. I can do 2 mutations on my aggregate, or 3 or 4, not limited. You can do as many things as you want, and the idea is because I can only return fulfillment or error, I can't return, well, I only did half of it. So that's where the unit of work comes in. If do a thing, that first mutation fails, or succeeds, sorry, and then the second one fails, the exception is thrown, I return an error, and the first thing never happened in the first place because I never committed it. So I've either done the command or I've not done the command, but there's no I did some of the command, because then you can leave your application in an inconsistent state, which isn't what you want. You can kind of think of the blue circle, the application layer, as that transaction boundary. I do. So from outside of this layer, you send something in, and you don't really care that there's a transaction going on. You just get back it's successful or not. You don't really care how many things are going on. Remember I said domain events get raised when you mutate things in aggregates, so they get raised. So you have to dispatch those domain events, because remember I just added them to a collection. So your command handler, or your command side of your application, is responsible for dispatching the domain events. And then you might have domain event handlers in the blue circle that make even more changes. And perhaps they even change other aggregates. That's quite controversial, that. They can change other aggregates, if you want. Maybe you don't want. So those last two things there, the committing the unit of work and event dispatcher, you probably don't want to write every command handler to do these things at the end. So at Oakbrook, we actually decorate our unit of work so you can't commit it without dispatching the domain events. I like to put these in a pipeline, like middleware, so you can have both of them, say we dispatch the events and then we commit the unit of work, and then you don't have to think of them. So that's commands. Let's do queries. The other side. Or was it that side? I can't remember where I was metaphor now. Queries. The read side. So similarly, you say get me something. It is verb something again, by the way, because maybe you can ask to read something, provide something, but they're queries. You'll recognize what they are when you see them. But get me something. And then similarly to the commands, we've got a query handler. Looks very similar. Handling a query. I'm returning something this time, because remember queries are about getting me data. They're not allowed to make changes. And you probably know what's coming next, right? Oh no, maybe you didn't see that one coming. No, there's no red circle. We are returning a projection. So we're returning a projection. I'm actually here going straight to the Mongo database, doing a little query and projecting onto that something object. Because you don't want to use your aggregates or your entities over here. Firstly, if you return those, people can mutate them. And this is the read side. You don't want them making changes. And secondly, just CQRS says they're whole different subsystems. My aggregates and entities are used for the command and the writing subsystem. Queries, I want to have their own system. I want to make them their own thing. So I return a projection. This something object is defined in this part of my application. You could even use, so think view models. You could do a join here. Maybe you're using Entity Framework for your command side, and you're using Dapper to do a join on your read side, and you're joining across 7 tables to return a result. Maybe you have the freedom to do so because you've segregated those responsibilities. You could even use a separate database. You could have a Mongo database for your commands, and you can have a SQL database for your reads. That's called a read store. So whoa. Check that animation as well, by the way. Did I just say I drew a big blue circle around a red circle, and then I divided the blue circle in half, and I said you can only use the red circle in half of it? That's silly. Well, we debated this a lot at Oakbrook. We wondered, well, what about value objects? Can you return value objects in your query results? If I wanted to return a sort code, I've already got this object there. I've got the dependency on the domain, so I can use it. Can I just return a value object? Now, if you Google that, ask the question, can I use DDD value objects in my CQRS queries? You come across a Stack Overflow post with 2 answers. One says yes, one says no, and they both have the same number of upvotes. So I don't know. We went with yes, because we thought, why would I want to re-implement this object? But I think when it gets to the point where we need to separate them, and we realize there are separate concerns reading, sure, we'll start using a different object. But we do use value objects in our queries. There's another one, though. There is a reason. There is a reason to depend on the domain, and that is event sourcing. Remember domain events? So this is my read side, my query side of my application is listening to, or subscribing, to those domain events. And then when it handles them, it builds up that read store. Do you remember I mentioned the read store? In fact, do you remember I said you could do a join across 7 tables? Well, what what if only one person can do writes, they've got permissions, and you've got 1 million queries a day doing this join across 7 tables, but you're only writing in the morning? That seems very inefficient. You might want to optimize your query side, but you don't even need to touch your command side. You just change it from doing a join to 7 tables to when the command happens, we'll pick up the domain event that happens off the back of the command happening, and then we'll start building that table ourselves, and we'll just select the rows from it. So we'll do the joins when the command happens. We'll make a denormalized table with all the data that we need. One thing to know here, so black arrow is a dependency, domain, application, commands and queries, both to point inwards, but the flow of control is remaining going left to right. Command comes in, changes stuff, domain events go out that way. So hang on, I kind of lied a little bit earlier, didn't I? I said there were 2 things in the application, and then I went on about domain events a lot. So there are domain event handlers within an application. They're not really the public part of the application, I guess. Commands and queries are things that you can send your application, but domain events handlers, they happen inside, internally. There are 2.5 things you can do in a domain event. You can write to a read store, as I was just saying. This is all within the same transaction, by the way. So when I was building up that table, it's all committed as part of the same transaction. The blue circle is the transaction boundary and my application project. So I can write to a read store. Here, when the car gets painted, I'm just building up a little stat database that I'm going to sum later. Or remember, I can make further changes. So I can reduce the amount that's in my paint can. And then maybe that reduce throws an error because there's not enough paint left. And then my original command would fail and the transaction doesn't get committed. That's a whole separate class. And the other half thing that you can do is schedule jobs. Now the reason I say half thing is because that's kind of a query. All you're really doing is building up a read store, like a table of jobs, and then later a job process is coming along from the outside and sending queries to your application layer saying, have I got any jobs to do? Have I got any jobs? It's polling. So it's kind of a half thing because it's kind of queries. But I wanted to give it a special mention. So now my colleagues at Oakbrook are probably looking at me funny because we can't do that. We can't schedule jobs within the transaction. And I'm going to say we do. We do it in every service, but we just have a non-abstract version. We have a very concrete job scheduler, which we call the event stream. So we have what is, in essence, a generic domain event handler that picks up every domain event and serializes it and puts it in another collection. That's a read store. It's the event stream. And then we have a job processor that sits outside of the application layer that picks up all of those events and sends them off to an event bus. We use Google PubSub. You can use RabbitMQ. You can use whatever you want. Oh, you can use that to build up a read store as well. Remember I said you can use a SQL database? We do. We use that to build up a SQL database. We handle those events, the integration events there. But I'm getting ahead of myself. You still with me? That's CQRS. No, nobody's with me though. I've lost you all. That was the application layer. CQRS, these building blocks, how they all fit together. The infrastructure layer, onion architecture, points inwards. Dependencies go inwards. So these are the things outside our application layer that are sending the commands and queries to our application. Often divided into 2. So you will often see an onion architecture diagram that looks a bit more like this. In fact, the one I showed you earlier was divided into 3. The infrastructure layer actually had a presentation sort of part to it. So this is the flow of control. This is ports and adapters again. We've got our driving adapters over here on the infrastructure layer, and we've got our driven adapters over on the right-hand side. Sorry, presentation layer, infrastructure layer. Remember? Check that out. We've got controllers. They send things into the application. They're driving. And the database, that's the driven adapter. That's on the infrastructure side of things. And remember, in ports and adapters, we also had external APIs. We could make third-party API calls. outside. They've driven the application. You might have, actually, this is where I think the whole flow of control thing breaks down. And I know I've spent like 45 minutes banging on about it. But when we talk about presentation and infrastructure, right, my external APIs are making calls, that project is making calls to external APIs. Perhaps my application layer declares a port that's the money sender. It goes, I'm money sender. It doesn't know how, but it just needs to send money. And my external API layer is maybe going to use PayPal to do that. Or the project, sorry, is going to use PayPal. And yeah, I'm going to make some HTTP calls over to PayPal's APIs to send some money. But then later, PayPal needs to, well, it doesn't need to, but I might want to handle webhooks that come from PayPal. So they're going to call me. And I wouldn't expect those calls to go right the way around here and then come into our presentation layer, into our controllers, just because they're controllers. I would expect the class library that's responsible for dealing with PayPal and translating PayPal to be doing the PayPal stuff. So I would expect the models that understand what PayPal is to all live in that one class. Perhaps this is a misunderstanding that I think most people go through, and I've definitely gone through, where you think these boxes are C# projects, but maybe they're not. Maybe they're just things on a diagram, and you can have different boxes for your structure, for your project structure. But I think everybody looks at application and domain, and they make C# projects from this. So I'm going to say they are C# projects, and say this is the PayPal project that understands PayPal, and it also understands my domain. So it is its job is responsible for translating PayPal's language into my ubiquitous language. That's called an anti-corruption layer in DDD. I'm not going to say it again because it's a horrible word. Anti-corruption layer. So it's the project that's responsible for translating another language into my own. So if PayPal can send me webhooks into my infrastructure layer and the flow of control is going that way now, then I'm also going to put integration events over here in the presentation layer. Whoa! Why has he put integration events in the presentation layer? I've not seen a diagram on the internet that does this. And the reason I think this is, these are your public contracts. These are what people see. When I see the word presentation, that's what it's about, right? This is, I'm presenting to the world. I'm presenting my service to the world, and this is the public bits. These are the internals, like our classes from the first slide. And then I see this. These are the things I'm going to put in my documentation. And the flow of control. It goes into the controllers, and it goes out through the integration events. So I've no longer got my big yellow arrow going across. So if PayPal's on that side doing the same thing, something calling me is seeing this side. Check this out. You could have two services where one of the external APIs sees the presentation layer of another service, and that's anti-corruption layer, sees another service. And now all of a sudden, when I'm looking at this sort of scale, the arrow there is about dependency and not control. I have a direction of dependency, but the flow of control between these services is going both ways. I can zoom out, and I can have loads of services. And maybe these are all onion architecture, but you might have different architectures and different services. And I've got like a flow of dependency. All the core services that don't depend on anything are over on the right-hand side, and all the things that depend on them are to the left. I've got like a big architecture diagram. And you can draw even more boxes around that, but I'm not going to go into that. That's probably a bit too much. And namespaces or domains. Right, that's it. That's all I got, except I'm going to try and give you the TLDR, or didn't listen. You ready for this? So, from outside, I call a controller in my presentation layer that sends commands to my application layer, which load aggregates from the domain via repositories, which are implemented in the infrastructure layer as a write store. My aggregates contain entities, value objects, and raise domain events, which are handled in the application layer by domain event handlers, which may make further changes to my domain or write things to a read store, which can later be queried by resilient jobs such as publishing integration events, writing to an external read store, or calling external APIs. Thank you very much. I've been Connell Watkins. Please do find me on social media. I've got no followers because this is my first talk I've ever done.